Hi everyone, today we're going to be covering lessons 4.2 and 4.3. Hopefully you've had a chance to go through the content so that you know what's coming up and what I'm going to be going over. If not, that content is still available. I highly recommend going through it. If you are relying solely on my videos and our live class sessions, you are missing out on content and you will not be doing as well in the course as you could be. So please make sure that you are dedicating the time to going through that content so you know everything that's expected of you. Okay, so today we're going to start with 4.2. One important concept from 4.2 is knowing the distance formula. So the distance formula says that d, lowercase d, we're going to call that distance, is equal to the square root of the difference in the x value squared. Difference means subtract. Plus the difference in the y values squared. You may also see it written flip-flopped like this. It doesn't matter which way you write it. All it says is, well, I picked these ones to be my x and my y first point, and another person picked to start with the other point first. It doesn't matter as long as you stay in the right order. So I have x1 minus x2, y1 minus y2. If I flip-flopped it, then I got x2 minus x1, y2 minus y1. They're both the same. It doesn't matter. They work exactly the same way. You need to know the distance formula though. So pick one that you like, and that's the one that you're going to need to memorize to use. It's not on a formula sheet anywhere. We're going to use that formula to calculate the distance between 2 points. So I like starting with the 1. Okay. These subscripts are just part of the name of that point. It doesn't mean we're doing anything to that number. It's just part of the name. So what you're going to do is find the coordinates of the 2 points. And if it's not given to you, you'll have to actually find the coordinates. So that first point is at -5, +3. And the other point is at -2, -3. And then what you're going to do is you're going to go to your point and you're going to label them. You know that every coordinate has an x and a y coordinate. The first point gets the sub 1s and the second point gets the sub 2s. And that will tell you what exactly to plug into the distance formula. So d equals the square root, and then we're just going to plug each number into the formula. x1, that's -5, minus x2, x2 is -2, plus y1 minus -3 squared. You should recognize that subtracting a negative is the same as plus. So this is really -5 plus 2 squared plus -3 minus -3 is really 3 plus 3 squared. And then you're going to evaluate what's in the house there. Okay, so I got the square root. -5 plus 2 is -3. A -3 squared is a +9. 3 plus 3 is 6. 6 squared is 36. So this is the square root of 45. Back at the beginning of the school year, I asked you to review some Algebra 1 material, and part of that was simplifying a radical. If you didn't do that or you need a refresher, that material is still open and available for you. For 45, I recognize that as 9 times 5. So the square root of 45 is the same as the square root of 9 times the square root of 5. Well, the square root of 9 is 3. So my final answer is 3 root 5. So the distance between those 2 points is 3 root 5. If it had asked me for a decimal, I could put this in my calculator and round for a decimal. Let's try the second one. D equals the square root, and you need to label your points. X, Y, X, Y. From the first point, give it sub 1s. The second point, give it sub 2s, and we'll plug that into the distance formula. x1 is -4 minus x2 is 3 squared plus y1 minus y2 squared. -4 minus 3 is a -7. -7 squared is a +49. 1 minus -1 is 1 plus 1, which is 2. 2 squared is 4. So I've got the square root of 53. 53 is a prime number that can't be simplified anymore, so my final answer is the square root of 53. One of the biggest mistakes that I see students make when doing this type of problem is they don't square their numbers correctly. So please be very, very careful when doing that. Please remember that any number squared is always positive. Okay, so a positive number squared is positive, and a negative number squared is still positive, because when you square a number, that means you're multiplying that number by itself. So a negative times a negative, well, that's still positive. And a positive times a positive is still positive. If you're entering it in your calculator, it is vital that you put parentheses around that number. So here I had -7. If you type parenthesis -7 squared in your calculator, it'll tell you 49. But if you type -7 squared with no parentheses, it's going to say -49. And that's not correct, because any negative squared is still positive. So be very, very careful when squaring your numbers, especially if you're relying on a calculator. Another formula that we need to know is the midpoint formula. The midpoint formula says we're going to average our x values together. That'll be the x coordinate of the midpoint. Remember, average means add them up and divide by how many there are. And I have 2 points, so I divide by 2. The y coordinate of your midpoint is the average of the y values. And then just like in the distance formula, you're going to label your x and your y's. So it tells me that G is at 7, -5. That's an x and a y coordinate. H is at 9, -1. That's an x and a y coordinate. From the first coordinate, I give it sub 1s. And from the second coordinate, I give it sub 2s. So to find the midpoint of GH, I'm going to plug my x's and y's into my midpoint formula. So this will say 7 plus 9 divided by 2. That'll be the x coordinate of the midpoint. -5 plus -1 divided by 2. That will be the y coordinate of my midpoint. 7 plus 9 is 16, divided by 2 is 8. -5 plus -1, well, that's -6, divided by 2 is a -3. So the midpoint, or the point that's exactly halfway between G and H, is at the coordinate 8, -3. At this point, I'd like you to pause the video. Find the midpoint of AB. Label your points, plug them into your formula, and find the coordinate of the midpoint. Please pause the video and do that now. Okay, so you should have gotten the point -2, 0. If you didn't, I recommend going back and checking your algebra, checking how you plugged in the numbers, make sure you added correctly, make sure you divided correctly. Another type of problem we'll see with midpoint is if we're trying to find a missing endpoint. The way that the content teaches this is going to be different than what I'm about to show you. Personally, I think my way is easier, but you can do whatever way works for you. I call my way the box method. So you're going to make a box with 2 columns and 3 rows. Each column will represent the x or the y coordinate, and each row will represent a point. The midpoint will go in the middle, and the endpoints will go on the top and bottom. And I usually save that bottom row for what I'm looking for. So it says find the coordinates of A. So A is the point I'm looking for. If M is the midpoint, M is my midpoint, and B has the coordinates 3, -5. So then I fill in the coordinates. The coordinates of B are 3, -5. The coordinates of M are -1, 2, and I'm looking for the coordinate of A. Think of X and Y as our number lines, which is what they are. X is a number line that runs horizontally. And what I'm saying is the B is at 3, and the midpoint is at -1. So that's my midpoint, which means there's some other point over here making this distance and this distance the same, because midpoint has that point in the middle. So how would I go from a 3 to a -1? Well, I would subtract 4. So to get to the other endpoint, I'm going to subtract 4 here. I need to subtract 4 again. -1 minus 4 is -5. And then I think of it the same way here for my y values. Y is a number line, and I've got a point at -5 and a point at +2. That 2 is the midpoint, which means there is some other point over here that's the exact same distance away from 2 as 2 is from -5. So how would I go from a -5 to a +2? Well, I would add 7. So to get to the other endpoint, I do the same thing. So A is at the coordinate -5, 9. If you like my method, you are welcome to use it. If you don't like my method and you like a different method, you're welcome to use that too. Whatever works best for you. At this point, I'm going to ask you to pause the video again. Try number 7. Find the coordinates of J if K is at -10, -5, 10, and the midpoint L has the coordinates -8, 6. If you like the box method, try that. If you like a different method, use that. Please pause the video and do that now. Okay, you should have gotten J at the point -2, 14. We're going to switch up just a little bit here and talk about areas. There's a formula slide in your PowerPoint that has a bunch of formulas for area, and you will also be given the formula sheet for the SOL. I posted the formula sheet to OMHS, so you should be able to access that there, and you may use that formula sheet on any assessment from now until the end of the year. So if it's on the formula sheet, you may use it. Okay. We are going to see some things called composite figures. A composite figure is a figure that can be separated into regions. So it might look like a really funky shape, but you can break that really funky shape into regions that we're familiar with: triangles, parallelograms, circles, rectangles, so forth. If I want to find the area of that composite figure, then I'm just going to divide it up into the regions that I recognize and find each area. And then I'll take each of those small areas to find the sum of the entire thing. And we'll see that here in just a minute or two. Before that, though, let's just practice finding the area of some of these shapes. And you should have found area of shapes before, but just in case, here's a little review. The first thing you always want to do is ask yourself, what shape am I looking at? This looks like a square to me. So looking at my formula sheet, I look for the square. Here it is. And I want the area. There's 2 formulas there. Pick the one for area. Area is the capital A. A equals S squared. S is the side. And if you didn't recognize that, in the picture, the lowercase s is labeling the side. So for our formula here, we're going to use area equals side squared. Well, the side here is 8.5. Oh, hey, calculator, it's 8.5 squared. Okay, type that in your calculator. Calculator will say, well, that's 72.25. Now we need a unit. Okay, our sides were in feet. Feet times feet, or feet squared. Okay, because I'm doing feet times feet, my unit will be feet squared. You may also see it written as square feet. It's the same thing. Whenever you're calculating an area, your units will be squared, always, 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 always. In the next example, I have a triangle. Try this one. Go back to your formula sheet if you need to. There it is. Find the triangle, find the formula for its area, and looking at the picture, plug in the numbers and calculate the area. So pause the video now and do that. Okay, so you should have gotten on 159.75 meters squared. The base was 15 and the height is 21.3. In any shape, your base will always be perpendicular to the height, always. So because I see a right angle here, I know that this will be the base and this will be my height. Don't forget your units. Your units are meters squared. We have some more figures here just to practice finding area. This first figure is a parallelogram. The area for a parallelogram is 1/2 base times height. So in my parallelogram, the base is 12.9 and the height is 7.1. So the area is 12.9 times 7.1. Type that in your calculator. You get 91.59. Don't forget your units. Because we're calculating area, our units are inches squared. In number 5, we have a trapezoid. Okay, so in a trapezoid, so we're looking at a formula sheet. Here it is. The area is 1/2 times the height times the sum of the bases. Okay. So this trapezoid is on its side. That's okay. The bases in a trapezoid are the sides that are parallel to each other. And it doesn't matter which one you call base 1, base 2. I'm going to call this one base 1 and this one base 2. Remember, the base is perpendicular to the height. So the height is 5. What? But it's sideways. Well, that's okay. If I lay down on my bed, my height doesn't change. So this is kind of the same thing. It's just turned. The bases are the two sides that are parallel. The height is the distance between the two bases, and they are perpendicular. So I'll plug that into my formula. Area equals 1/2 times the height times the sum of the bases. So this will be 1/2 times 5 times 7 plus 13. Okay, and I plug all of that in my calculator, I get 50. My units are millimeters squared. Now we're going to start talking about the composite figures. There's no shape on our formula sheet that looks like this. However, I do have a shape that's a rectangle. Here's my rectangle. And I have a shape that is a trapezoid. So we're going to do this in 2 steps. First, we're going to find the area of the rectangle. Okay, and I usually write that with like a little subscript so I know what I'm talking about. So this will say area subscript rectangle. And I can look at my formula sheet. The formula sheet says that it's length times width. So the length of my rectangle is 23, and the width of my rectangle is 12. And if you had those flip-flopped, that is perfectly fine because multiplication is commutative anyway. You can switch them. So the area of my rectangle is 276 centimeters squared. Now I have to find the area of my trapezoid. Okay, so I'm going to call that area of my trapezoid. And the area of a trapezoid is 1/2 height times the sum of the bases. So here the height will be between the two bases here. This will be the height. One base is 15 and the other base is 23. But it doesn't tell me the height. It tells me this entire distance is 18, and I know this distance is 12, which means this distance must be 6. So the height is 6. One base is 15 and the other base is 23. And if you had those two numbers flip-flopped, that would have been fine. And I calculate this and I get 114 centimeters squared. So to find the area of the total thing all together, I like to call that area of total just to keep all of my work straight. I'm going to take the area of my rectangle and add that to the area of my trapezoid. So the total area is 390 centimeters squared. So that's how you would find the area of a composite shape. Break it into the shapes that you know, find the area of each one, and then add them together. And now we're going to take both of those things and we're going to put them together. We talked about distance formula. We talked about areas. Let's use them together. We're going to find the area of this figure. What shape am I looking at here? I'm looking at a rectangle. We know that the area of a rectangle equals length times width, but it didn't tell me the length or the width. So that's where the distance formula is going to come in. So we're going to use the distance formula to find the length. Okay, so let's find the length of CD. So I'm not going to call it lowercase d anymore. I'm going to call it CD because that's a distance. Okay, so let's see. Let's label x, y, x, y. From the first coordinate, they get sub 1s. From the second coordinate, they get sub 2s. So this becomes -1 minus -4 squared plus 2 minus -1 squared. So this is the square root. -1 minus -4 is -1 plus 4. That's 3. 3 squared is 9. 2 minus -1 is 2 plus 1. That's 3. 3 squared is 9. So this is the square root of 18. The square root of 18 can be simplified. 18 can be broken between 9 and 2. So the square root of 18 is the square root of 9 times the square root of 2, which is 3 root 2. So the length of my rectangle is 3 root 2. And now I need to find the width. So let's find the width. So let's find, you could find CB or you could find DA. They're the same thing. I'm going to say DA. Okay, so now, well, I didn't have to do that. I'm going to say, all right, A is x1, y1, and I'll let D stay x2, y2. So this will be the square root, -2 minus -4 squared, plus -3 minus -1 squared. -2 minus -4, -2 plus 4, that's 2. 2 squared is 4. -3 minus -1 is -3 plus 1 is -2. -2 squared is 4. So this is the square root of 8. Well, the square root of 8 can be simplified. 8 breaks down into 4 times 2. So this is the square root of 4 times the square root of 2, which is 2 root 2. So now I know my length and I know my width. Now I can go back to calculate the area. So the area equals 3 root 2 times 2 root 2. And you can move these around if you need to because the multiplication allows you to do that. You could say, oh, well, this is 3 times 2 times root 2 times root 2. You don't have to do this step if you don't want to, but I recommend it. This becomes 6 times, well, what's root 2 times root 2? Well, that's the same as the square root of 2 squared. A square root and a square cancel each other out. So root 2 times root 2 is 2. So the area of this whole thing is 12. And because it didn't give us units, I'm just going to say units squared. If you need to review radicals, I highly recommend doing that. Okay. The last example in these notes are looking at a triangle here, and we're going to calculate the area. So we look at our formula sheet, and the area equals 1/2 base times height. So we're going to have to find the base. The base in this case is AC, and the height will be BD. So we're going to use the distance formula to find those. So on your own, You're welcome to pause the video. It'll pause in a moment. Find the distance of AC. Do that now. Okay, so for the length of AC, you should have gotten 3 root 10. And for the length of BD, you should have the square root of 10. So to find the area of this triangle, you're going to do 1/2 times 3 square root 10 times the square root of 10. So this becomes 1/2 times 3 times root 10 times root 10. Well, 3 times 1/2 is 3/2. Square root of 10 times the square root of 10 is 10. 3/2 times 10 is 30 over 2. So our answer is 15 units squared. Okay. So that was 4.2, and I'm going to switch over to 4.3, which is essentially the exact same thing. Okay, so the only thing in 4.3 is they added a few more word problems, but it's essentially the exact same material in 4.2. Okay, so I really only have one example here from 4.3 that makes it any different from the last section. Dr. Chavez drew a rectangle on a coordinate plane to estimate the size of the lake. Each unit on the plane represents 1 mile. The coordinates of the rectangle are at the origin, 0.0, 7.65, 12.8, 76.5, and 12.80. Based on this information, what's the perimeter and what is the area? So I'm going to sketch out what this picture looks like. Okay, so let's sketch it up. Okay, one of the coordinates is at the origin, 0, 0. One coordinate is at 0, 7.6. Well, I'll put that up here. 6.5. 12.8, 7.65, and 12.80. So here's my rectangle. Now we just need to find the perimeter and the area. Well, if we can find the length and the width, we can do both of those things. And to find those numbers, we need to use the distance formula. So let's practice the distance formula again. We could plug in 0, 0 and 7.65. However, if we are a little smart about this, we would recognize that the distance between 0 and 7.65 is just 7.65. And the distance between 0 and 12.8 is just 12.8. So the formula for perimeter says take 2 lengths and add that to 2 widths. So this will be 2 times, you could say 7.65 plus 2 times 12.8. And if you chose the L and your W to be flip-flopped, that's fine too. We're going to get the same answer. We're going to get 40.9. And our units are miles, not miles squared. This is a perimeter, not an area. And now we can find the area also. The area is length times width. So this will be 7.65 times 12.8. So we would go to our calculator and we would calculate 7.65 times 12.8. 97.92. So the area of this lake, 97.92. It's an area, so it's miles squared or square miles. I've never seen a perfectly rectangular lake, but there it is anyway. So that was 4.2 and 4.3. You're also going to want the attendance quiz word. The attendance quiz word is practice. The best way to memorize the distance formula is to practice. Practice. Please make sure you spell it correctly. I can't reopen the attendance quiz for you. Practice. Okay. I hope that this video was beneficial to you. Don't forget to do that K-12 content. Don't forget the attendance quiz, the lesson check. It's going to be very helpful to your grade to do well on those. If you need extra help, please reach out to me. I'm happy to help you. Have a great day, everybody.